All right. Here we go. Unit 3, two-dimensional motion, lesson 1. By the end of this lesson, you'll be able to describe how an arrow depicts a vector measurement, add and subtract one-dimensional vectors, apply one-dimensional vector math to resultant velocity scenarios, and calculate the unknown sides of triangles of a right triangle. Okay? Scalar measurements. These are measurements that have only magnitude. Okay? Not direction. Versus vectors are magnitude and direction. Yes? Right? Review. Get there? Okay. I have pressed yet. So these are the scalar. This is vector. Tell your neighbor.
Wait, displacement. But I'm not sure.
But based on what kind of head you are, he basically holds you back.
Brian, can talk about you, like he the fantasy football player,
Which he should.
most opportunity of all time.
Did you tell them that like the thing is every single trade I make I win? It's such like
Yeah, well, I didn't like actually talk to him. It was a pretty crazy round.
Correct answer is correct answer is what? E. Which two? C and D. Good. That's just magnitude, not direction. Okay. So pictorially, we're going to represent vectors with an arrow.
So displacement and direction.
Displacement has magnitude and direction. Acceleration has magnitude. So we represent a vector with an arrow. Obviously, the way it's pointing communicates direction. That's kind of a like no-brainer. The magnitude is represented by the length of the arrow. The longer the area, the greater the magnitude. Okay? With the displacement vector, that's pretty self-explanatory. The longer the displacement, the longer the arrow. But for velocity, the longer the arrow, the faster the speed. For an acceleration vector, the longer the vector, the greater the rate of change of velocity. The faster the velocity is changing. And force vector, the longer the arrow, the stronger the force. So you can have there's more vectors to come, but those are the ones you've been exposed to at this moment in time. Okay? So the magnitude is represented by the length. Okay? Tell your neighbor. Correct answer is there we go. C. Okay, the rabbit's moving faster in the opposite. Sorry, to the right. Turtle's going the opposite direction, slower. C. Okay. All right, resultant. The resultant of vectors. This just means the sum of. So anytime you see the word resultant, think, oh, I'm going to be adding things together. Sum of. All right, good? So, let's do some examples. 7 to the right plus 3 to the right gives you 10 to the right. 7 to the left plus 3 to the right gives you 4 to the left. Man, you guys are geniuses. 5 up plus 4 down gives you
1 up.
There it is. 4 down
9
plus
down.
5 down gives you 9. 9 down. Okay, so you see how easy that is. Okay, when we get to, so this is one-dimensional vectors. When we get to two-dimensional, what we're going to try to do is we're going to try to break it down to this stage here. Take a two-dimensional vector. I'm foreshadowing. I'm like giving you stuff that you don't really have a context for, but we're trying to get to this point here. This is easy. We like this. Okay? This is where we're going to try to get to when things get more complicated. Okay? So this is our end goal. This is a nice, happy place. Okay? This slide is like, give me a physics test about that. They're like, oh, we'll rock the socks off of that, right? Okay? Tell your neighbor.
No.
Correct answer is. There we go, they. Tell your neighbor. There we go, B.
Yes.
Yep.
So that's
That's what we're going for. Tell your neighbor. Here we go, C. Okay, and notice I started throwing some units on here, so we just found the resultant acceleration. And we have two different accelerations. The resultant of those two gives you 6 meters per second squared in the negative direction. Tell your neighbor.
Certainly. Bless you.
Correct answer is C. Okay. Here's the story. You walk 3 meters west, and then you walk 3 meters east, or 3 meters to the left, then you walk 3 meters back to the right. Your resultant displacement would be 0. You ended up back where you started. Okay, that's one application.
Easy.
Or a thumbs up, you got something? Tell your neighbor. There we go, C. Okay, this is known as resultant velocity, or relative velocity. This is the same idea, like if you were on a moving walkway in the airport. You're walking at a certain speed, and then you get on the walkway is moving at a certain speed. So your combined, your resultant velocity, or your relative velocity, compared to someone sitting just in a chair on the side, you're flying. Whoa! But you're just walking normal, but you're walking on a moving walkway. Does that make sense? Okay. Correct answer is C. We're adding those together. You've got the wind is going 40. The plane's going 200 in the wind. So combined together, as you're standing on the ground, you see the plane 240 meters a second. Okay? So what would happen if it was going into the wind? Tell your neighbor. There we go, B.
Yeah.
Okay, and this is actually what happens. So in the United States, weather patterns typically go out of the west to the east. They might come from the north, they might come from the south, but they're generally heading that way across the United States. So if you're flying, if you're going west, it takes longer. I'm not talking about time zone changes. I'm just talking about time in the air. It takes longer to go this way because you're fighting against that eastward weather systems versus going back east. It takes you shorter because you're moving with it. You with that?
I can't see that.
What is the bird's resultant velocity? What is the bird's velocity relative to you? 0. The bird is flying just as fast as the wind is blowing.
And some birds of prey, like the hawk or actually use this to their advantage.
Absolutely. You might have seen this
Oh, I've
video.
seen this.
They just fall.
Oh yes, I've seen that video.
Go with that.
Wouldn't that be zero too? Because
Yep. Yeah. The train is going just as fast as the cyclist is riding. That was kind of the whole point. Yeah? Tell your neighbor. Correct answer is
B.
B's. What does it look like?
This happens a lot with a lot of ships and like wind turbines.
Yep. So like if you find yourself in that scenario, you're getting owned, swim to the bank. That make sense? All right. What is another way mathematically to write A minus B?
A plus negative B.
A plus a negative B, or you might say negative B plus A. Okay with that? Now, with vectors, if you make a vector negative, what does that mean happens to its direction? Right, it reverses. Okay? It goes in the opposite direction. Do a 180-degree flip. You all right with that? Make it vector negative. Okay, so what we're doing, which one are we going to flip? A or B?
B.
Flipping B. We made that negative. But then once we flip it, that takes care of that negative, and then you're just adding it. You just find the resultant. So flip it, then add. Does that make sense?
Wow, that is a very trick.
Have a conversation. Tell them how you got there. This usually ends up being an interesting conversation.
since if being forced to write a negative, but then I think must be. It's because it's negative, so you see negative 6
I said D. Yeah, which means it's going left. Well, you might be right. Either way, you have to. Yeah, except the negative is different. It's not shared. The negative to the 6 to the right makes that 6 to the left. 6 to the left plus 2 to the left is 8 to the right.
Oh, right here. So is it predicting?
I am.
I was like, I think I'd rather go with. I got. No, I got.
You didn't need to calculate it. It was coming back from right.
Yeah.
Okay. What do you say? Correct answer is D. Dangerous dinosaurs. Okay? You're gonna apply the negative, so you're gonna flip this, and that becomes plus. So you have 2 to the left plus 6 to the left gives you 8 to the left. Good?
It's negative 12.5. What am I shared? For the trolley, bro. That's what I got.
Correct answer is?
A.
Correct answer is A. Okay, which one do we flip?
The B.
B, so it's now going up. So we have 12 meters a second up plus 5 meters a second up gives you 17 meters per second in the positive y direction. Good? Tell your neighbor.
How much you drink? It'd be going in town now. No, it's what?
Correct answer is B. Okay, we're gonna make this guy flip. 3 to the left plus 3 to the left gives you 6 to the left. Good? Thumbs up when you have something. Tell your neighbor and tell them why.
Why? It was going right. It's a graph. Left.
It went to positive direction. It was starting the positive direction.
Yeah. Once you flip it, you gotta share it.
You guys are like actually.
Correct answer is? Correct answer is A. Okay, change in is always final minus initial. So that's the application of the subtraction with vectors. Change in anything, final minus initial. So you have final negative 2 meters per second minus an initial plus 3 meters a second. Okay, it was going this way. So final minus initial. Make that go that way, plus. Good? All right. Doing some trig review. Okay.
Will SOHCAHTOA be used commonly in physics?
Yes. Oh, yes. Oh, yes. All right, so theta. That is our popular variable for an angle. Okay. Now, what kind of triangle do, like when we do sine, cosine, tangent, what kind of triangle is that? A right triangle. Okay, now.
You see the video of Jackie Egan pull over? He was 101 and 50. By your house actually, he was 101 and 50.
No, it was on 25. It was on
That's not
25.
far.
It was by East Ed.
It was like way out past my house.
It was on 25.
No, it's no, it's nowhere near.
Haley, on 25, like by exit 175.
It's nowhere near.
It's like by Bug Street. By Bug.
I think you pull over in group.
Yeah.
Yes, well, you have to pull over because you pass the car.
I know that.
Pass the car.
Oh.
Yeah, so.
Alright.
What?
The thing is, like, you should get rid of this.
35.
And it's good.
It was like, that's so great. It was like, yes, you could tell.
That's a bill. That's deal time. That's it.
That's another like 65. He's pass across. Exactly.
Because I had to do.
Adam, how much did your ticket end up being?
I haven't paid yet, 480.
180s? He went 107 on a 65.
Alright,
Gotcha.
alright, this is something, okay. Hopefully this is in your brain already. Sine is what?
Opposite over hypotenuse.
Okay, opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is, okay. I don't care how you get it in your brain, it just needs to get in your brain. Okay? People are like, Chief SOHCAHTOA. That didn't help me when I was in high school because I didn't really spell very well. I'm like, oh, is that no or an A? I don't know. Okay. Well, the way I did it, this is, people are like, that's messed up. I did it kind of alphabetical-ish. Like, I was like, okay, C is and A, those are close to the start of the alphabet. S and O, they're kind of close together in the same alphabet, and then tangent's like opposite of alphabetical order, goes O over A. That's how I did it. Weird. Dr. Mason, some old hippie caught another hippie tripping on acid. I'm sure you can chat GPT it and give me some way to remember.
Or think of it as like a spell, a very complicated one.
Sure, whatever. I mean, you got options, okay? Now, when we talk about opposite, adjacent, what these are referring to are the sides of the triangle relative to this angle, whatever the angle is, okay? Which of these sides is opposite? Which of these sides are opposite of this angle? A is opposite. So this would be your opposite side. Okay? Adjacent means touching. So like your neighbors have adjacent yards to yours. These two sides are adjacent to this angle. There's touching this angle. But one of them is a hypotenuse. Which of those is the hypotenuse?
C,
C. How do we know?
because it's slanting downwards.
It's the longest.
What is that? Because it's the longest.
It's the longest side. It's also opposite of the right angle.
Oh, that was opposite.
Okay.
See with that?
I didn't know how to explain it. It's not.
Is everybody okay with that? Okay, so this is hypotenuse because it's opposite of the right angle, and then this one is the adjacent because it's touching that angle. Okay? And what equation relates to the lengths of the three sides? Pythagorean theorem, a squared plus b squared equals c squared. Okay, all of this whole slide needs to be memorized. I hope it is already there in your brain. If it isn't, get it there. Yeah? Good. Okay. I will not give you this stuff on the test. Like this is on you. Okay? This, to be perfectly honest, this is that all this information on this slide, you'll use it the rest of your life. Not like all the time, but periodically, like, where's the khaki? I need to sign to that. Get this thing. Like it's just periodically, if you're working on stuff, building something,
Yeah, we did.
or like trying to do some landscape, try to figure out how much this comes in helpful. Okay? The rest of trig, not really, to be perfectly honest. But this, you don't like, yeah. In everyday life, this will come in handy. That'll be in your brain for the rest of your life. Yeah. Ask your parents. Well, no, don't ask your parents. If you know it, you can use it. If you don't know it, all right. Give that one a shot. Break out your calculator.
That part said he's gonna be so good this year. Yeah, I was like, okay, Parker. The second game, 15-point game, but I didn't.
Yeah,
I'm not sure that happens. Yeah, you'll get one touchdown. Yeah, with one target, I'm giving it.
Wait, like, I think of what happens after all
Yeah,
this.
this time.
Yeah.
That's a waste of everything that
It's like
time.
13 out of
And
5.
that one, no, what I would've did.
Correct answer is. Correct answer is 12.
What?
Whoop. What did you use to solve it?
Oh, wait, I
Cosine.
Oh,
Oh.
Okay. You don't have any angles, it's all sides, so it's the Pythagorean theorem. Which is the C? 13 is your hypotenuse. So 13 squared equals 139, subtract 25, gives you 144, square root of 12. What? Sorry, 169. Subtract 25 gives you 145. Good? It's a 5, 12, 13 triangle.
It's one of those that exists within the
Okay.
rectangle range.
All right. Make sure your calculator is in degree mode. Make sure you're calculating and not radians. If you're in pre-calculus, that's going to be an issue throughout the year. And here it's degree mode. So I'm going to walk you through it. Example problem. All right. B is what compared to 40 degrees? What side of the triangle is B? Opposite. Opposite of 40. Okay? 5 is what? Hypotenuse. Opposite of right angle. So which trig function am I going to use? Trig function I'm going to use. Sine. Because that has opposite and hypotenuse. So I am going to go sine of 40 is equal to B over 5. Yes?
Yes.
Okay.
So
We're going to bring 5 times sine of 40. Now, depending on your calculator, determines what you stick in first. If you have one that you can edit, like this, you're going to hit sine, find sine first. If you have one that is you have one.
Do you remember just had an average? Freshman year, thought I was the coolest thing. Freshman year, so I was like,
I'll use it, I'll take it, it doesn't work.
yeah. You're
All
on
right.
fantasy. What do you know?
So some of your calculators, I didn't see any, but some of them you have to hit 40 and then hit the sign. But if you have a all the calculators I just saw, you need to hit sign first. And times 40. So the correct answer is A. Are we good? Thumbs up. A. Oh, we're running out of time. Oh, we're about running out. Okay. Okay, tell your neighbor which trig function you're using. You got opposite, adjacent, tangent. So it's tangent theta is equal to 17 over 26. To solve for theta, what we're going to do? Inverse tangent. So second shift, whatever, tangent button, 17 over 26. Correct answer,
33.
A. I want to see it, thumbs up if you got that, 33. Yes, I rounded. Are we good? Okay. Here's the only one that gets tricky.
wow.
Which trig function? So sine 42. Watch this as you walk out the door. Do not do 7 times sine of 42. You got to bring that over. Okay. Free quiz due tomorrow.
Chapter so often that you
What
don't
are you?
The thing is, McCaffrey, if you play